All right, everybody. This is Rush Mahabra again, signing on from Wayne State University, trying to come back with my Calc 1 YouTube series. The last video I feel like was chunked out a little heavily. So I'm going to start cutting the information up into not multiple videos per se, but trying to make it so the topics don't seem so bulky. So today, what we're going to talk about, we talked about finding limits from graphs last time. The notation, the idea, just introduction limit was the last video, so just finding the idea of that as the x values, and this is what you need to say to yourself. So anytime we're talking about the limit, and I feel like we all need to have a good understanding of the language, and this is what we're saying. So let's say they were to say find, and I'm not even going to give you a function, the limit as say x approaches 0, as x approaches 0, let's just give me a number, 3, right, of a particular function, right? They want us to find this. Well, in order to find that, we need to understand a couple things. What are they asking us for? Why does this keep doing this? I have no idea. Well, what are they asking us for is the big question. Well, what they're asking us for is this, and this is what this is what you need to tell your brain, or your brain needs to tell you. I don't know how you guys work, but I kind of have to tell my brain sometimes. This is saying is that as the inputs approach 3 from the left side, the function, the outputs, the y values, is going where? That's what we're trying to figure out. That is the first piece of the puzzle, and the second piece is this: as x approaches 3 from the right side of the function, what's happening? Okay, and this is a very, 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 very big thing. Okay, and if you can kind of get your head wrapped around the idea that we're not trying to plug in 3, but just figure out what happens at 3 by looking at what the values are going towards. That's what we're trying to figure out. And I know it's not an exact science, but we will get there. And what we're trying to elaborate is this idea of common sense. Okay, so now mathematicians will not write it like this, obviously, because mathematicians do not believe in. My Desmos really wants to come out and play because it keeps popping in. Okay, so mathematicians really do not write things like this, if you haven't figured out by now. Okay, we are just not a fan of this stuff. We actually write it like this. So in order to figure this out, we have to figure out two pieces. Piece 1 is to figure out the limit as x approaches 3 from the left side, and figure out the limit as x approaches 3 from the right side. If I could figure out these two, and they're the exact same value, call them some value, I don't know, smiley face. Then if these two are the same value, part 1 and part 2, then we can say that the full limit, which is the limit no matter which way you approach 3. This is what we're chasing, is this thing, right? No matter which way we approach 3 of that function should be whatever that value smiley face is. I love using smiley face. It's one of those variables that I feel like the millennials came up with, right? All the emoji stuff. You guys are making your own language. I got to give respect to it because math is its own language, right? And y'all communicate like that. All right, and I don't know who y'all is, but all right. So let's talk about some freaky deakiness with functions. And I always try to say that even though you know a whole bunch of stuff and how you've used it, the same things you've used have a different meaning or have a deeper meaning in different contexts. So we need to take a look at it. All right. So let's take a look at this guy. Consider the function this. So and this is what we did last time. We actually learned how to take functions by graphing. So I'm going to do a little bit of review here, but I'm going to make your graphs a little uglier. Because that's what we're interested in. We're interested in completely hideous, ugly graphs. Okay? Because we take limits because of these completely hideous, discontinuous, ugly graphs. So here we go. So this is what I want to do here. First things first, let's use Desmos again. And I'm going to see if I can actually make an absolute value here. I'm going to need a keyboard of some sort. So let's do absolute value. We're trying to graph the absolute value of x, right? Divided by x. Now, this is really, really weird. So you tell me, and I'm going to copy and print screen this so I can put it back on my notes here. So this is what the graph looks like. Okay, the graph looks like this blob. I'll put it right here. I'll blow it up for my people who are ocularly impaired, who could see it. What in the heck is going on with this graph? It's a flat line one way and a flat line another way. And these are the things we're more interested in, I think, when we start talking about limits, are these hideous guys. Here's our job. Find the limit as x approaches 0 of the function. Now note, I said this last time, you cannot find the limit by plugging in 0. Check it out. If you plug in 0, what happens here? You get 0 over 0. What the heck is 0 over 0? Nobody knows. It's not to be determined. It's a very weird thing. Like 0 over 0, cut something into no pieces and take none of them. Like, what does that even mean? That's really weird, okay? So, when we're talking about the limit as it, let's look at this picture, okay? We need to break this into two pieces. We need to see if we can determine what the limit is as x approaches 0 of the function. But as we're coming from the left-hand side. So as we come from the left-hand side, the x values are getting to the left-hand side, and we're approaching 0. Notice the y values stay constant at -1 all the way across the board. So I could tell you that the limit of this guy is going to go to -1. Done. Let's do the other one. The limit as x approaches 0 of 0 from the right. Well, we'll come from the right-hand side. I'll make that green. So as the x values approaches, notice I'm on the x-axis, and we're approaching. Note the y values aren't fluctuating. This thing looks like it's going to what value? +1. So what do we say now? This is where you get credit for everything that you've done in calculus right here for the last two videos. The limit as x approaches 0 of f of x. What is the answer? The left side's telling one story, the right side's telling another story. This guy does not exist. Okay, very, very simple. Now, sometimes we're not interested at, and we always want to see what's happening at these 0 points. That's why we are at these breaks or discontinuous points, and that's really what we really want to take our limits for. Like, you could do this limit, the limit as x approaches 3 of this, right? But check this out. Let me get rid of my entire writing on my graph. We're now talking about at 3. We're no longer approaching x. So you can kind of see here that as x approaches 3, the value here is still at 1. So that means the limit as x approaches 3 from the left-hand side, the negative side, has to be 1. And if we come to it the other way, that the y value still is 1. So the limit as x approaches -3 from the right-hand side, too much coffee, guys, equals 1. So what's the conclusion? Therefore, so this is another example. What is this? The limit as x approaches 3 of the absolute value of x over 3, that guy equals 1. So notice here, we're always talking about limit at a certain x value. Where are we going towards? At 0, it doesn't exist. At 3, it's at equal to 1. So it's not just a matter of plugging in values. People they're rudimentarily just bring it down to that. It's not that at all. Okay. So I want you guys to have that clear understanding. All right. So let's continue on, and I think this one might just be a graphing video. I feel like that's a good place to keep us at. So I want you to take a look at this graph. So here's a completely hideous graph. I want you to find a couple things. And the point I'm trying to get across to you guys is that you cannot plug in the value to get the output. It's not always true. So for example, let's let f be given by this. So at 1, 1, you have an open circle. But then I'm going to make it closed by doing this. And then 2, 3, another open circle. This is a flat line, 0 slope on it. This picks up here, and then it flies out. This is a 4, and it flies out forever. Okay? Fairly simple. All right, so this is what I want you guys to check out. Let's do, I'm going to call this part A. Find the limit as x approaches 1. And I feel like if you just can mentally keep it, in fact, sorry guys, that we're talking about as x approaches 1 from the left side and the right side. So where's the x values going to? Right here. That's 1. So let's approach it from the left side. It looks like the y values are getting closer to 1. So that means one side of this is the limit as x approaches, oops, that's an arrow, not a plus sign, approaches 1 from the left-hand side. The function should go to 1, right? Now let's take it from the left-hand side. And you notice instinctually after a while, it becomes pretty good sense that the idea behind a limit is that it's going to the same place. As x's go from here, it's going to go to the exact same place. It's kind of like both of you guys are heading toward the same place in the road. Even though there might be a pothole, there might be a ditch, you're still heading to the same place from the left and right. So therefore, we know that the limit as x approaches 1 of f of x equals 1. And I want you to check this out. Oops, not 11, 1. What is, so here's b. What is f of 1? Yeah, f of 1 is 2. The limit going towards 1 and when you plugged in 1 are not the same value. Okay, be careful. So the limit has nothing to do with the output, and I can't stress this enough. It has nothing to do with the output. So it could give you the same value as the output, or it won't. Okay, so check this out. The limit as x approaches 2 of f of x. I want you to find that. Pause the video right now. Figure out what that is, and then I want you to figure out what f of 2 is. Okay. Now, welcome back, and if you've paused the video, I know you guys did great things. So as x approaches 2 from the left, so let's get rid of so forget the black lines, let's call them my yellow lines. So as we're going towards 2, it looks like it's going to stay at 1, right? So that's from the left-hand side, okay? So limit as x, yes, and it is a lot of writing to keep track of the notation, but if you don't do it, you don't communicate the language properly, and that is what's important, that you're actually saying, putting periods and exclamation points and commas and everything else that goes in any language. As x approaches 2 from the right-hand side, it's still going to the same place. Which is 1. What's the conclusion? The limit as x approaches 1 of f of x equals 1. Are we approaching 1 or 2? 2. Got it. All right, and then the question again, that was part D, was what is f of 2? If you plug in 2, you also get out 1. Isn't that nice? And actually, I'll give you a little jump ahead. This is something special. When the output and the limit are go to the same place, this is actually the definition of what we call continuous. This is section 2.5, okay? But my point is that the output is not necessary in order for the limit to happen. Notice this limit output was different, not necessary in order for the limit to happen. Check this out. What is about this? What about, let's say E? What is the limit as x approaches 3? Again, you'll check both sides. The limit as x approaches 3 from the left side. Here is the number 3. It's going towards 3, which is right here. Looks like it's staying at 1. Oops. Oh, that's cute. Stays at 1. Right? Now let's approach from the left side. Looks like it's going to go to 2. Limit as x approaches 3 from the right-hand side. The function, the y values, are going to stay at 2. Well, are they the same? Nope. So what's the conclusion? The limit as x approaches 3 is inconclusive, i.e. does not exist. Okay? Look, the limit doesn't exist, but f of 3 clearly has an output at 2. So again, the output has nothing to do with the limit. All right, so that is my big point of the day. Let's see how we're doing on time. Do I have another 13 minutes? We have time for one more example. So I guess this is a good time to actually break down how we move from picture into common sense. Because the next video, we're not always going to have time to draw a picture. Even though we have graphing calculators, we're not always going to have time to nail down certain things. So this is what I want to bring to you. Or maybe I'll just save it for the next video. Yeah, I'll save it for the next video. All right, guys. So this is a short one, but I do feel like this idea of nailing down how to determine a limit from a graph is very, very important. Remember, the limit from the left and the right have to be approaching the same place as that x values go towards it. Now, it does not necessarily mean anything about the outputs. Don't even look at the output. That is not the right way to do it. You always look at what's happening as we go towards the outputs. Okay. Once again, guys, if you want to do something or go somewhere you've never been, you got to do some things you've never done. This is Rush Mahaber again, signing off, and I will see you on the next video. Bye-bye.